In this video, we are going to talk about vectors and what they are. So whether you're in a physics class, calculus class, linear algebra, hopefully this will be a good introduction to vectors. They're a fundamental building block for a lot of engineering classes. So let's start off with just a formal definition of a vector. Now, if you're Gen Z or if you have kids, you probably have seen this guy from Despicable Me. He's Vector, he's pretty iconic. But before we get to him, let's start off with a scalar. So a scalar is a quantity with magnitude. So this could be something like mass, for example. You could say 5 kilograms. A ball with 5 kilograms, it's a quantity and it has magnitude. You could also say time, for example, 5 seconds. This is just a quantity with magnitude. Quantity being 5, and we're magnifying it by seconds. But in Despicable Me, Vector introduces himself to Gru by saying, vector, a quantity with magnitude and direction. So for example, we could say 5 feet forward. So in this case, the direction is forward. Or you could say turn 10 degrees counterclockwise. So in this case, counterclockwise is the direction. So we use vectors to describe a magnitude, a quantity of something, but also give it direction. So you can think about a case like physics. If you tell me that a ball is traveling at 5 feet per second, that's great, but typically you also want to know the direction. Is it traveling 5 feet per second north, south, east, west? That's what makes vectors important, and that's why they're a fundamental topic for these kinds of classes. Let's now define how to properly notate a vector. So we have our variables. These can be x, y, z, and we can also have constants. These can be a, b, and c. Now let's start with just variable x. If I want to tell someone that x is a vector, typically what I'll do is draw an arrow on top like this. That arrow notates that x is a vector and has direction. Some people will also just underline it, or if you're reading a textbook, they will just bold the variable x to denote that it is a vector. Now if I have a three-dimensional vector, what I can do is write it like this. For our constants a, b, and c, it would be ax, comma, by, comma, cz. I can also write a vector vertically, ax, by, cz. Depending on what kind of operations you're doing with the vectors, you may prefer one way to notate it over another. Now, let's put some numbers into these to help make some more sense out of these vectors. Okay, so let's actually mathematically apply our knowledge of vectors. Let's start with this example. Given points P equals 2, 3, and Q equals 3, 0, plot the vector PQ and calculate its value. So let's start by plotting P and Q. So P has x coordinate 2 and y coordinate 3, so it'll be here. This is point P. And Q has x coordinate 3, y coordinate 0, so this is Q. Now, how do I actually plot PQ? So in order to plot P and Q, what we need to first do is draw a straight line that connects P to Q. And notice that Q is the second point in the vector. This means that the vector starts at point P and ends at point Q. So to denote this, we will draw an arrow pointing towards Q to show that we are starting at P and we are traveling to Q. So this is how we plot vectors in a two-dimensional space. But how do we calculate PQ? Well, in order to do that, we simply take the coordinates of Q and subtract them with the coordinates of P, because we are ending at Q, we're starting at P. So it will be the x-coordinate of q minus the x-coordinate of p. That would be the x vector. Then we would take the y-coordinate of q and subtract it with the y-coordinate of p. So the vector pq is equal to 3 minus 2, comma, 0 minus 3. So the vector pq is equal to 1, comma, negative 3, meaning that the vector pq travels 1 unit in the x direction and negative 3 units in the y direction. And you can verify this by seeing to get from p to q, you have to travel 1 unit in the x direction and 3 units in the negative y direction. The next important function we'll discuss is finding the magnitude of vectors. So I have the same vector here, pq, which in the last slide we found was equal to 1, comma, negative 3. Again, the x component is 1, the y component is 3. Negative 3, sorry. How do I calculate the magnitude of vector pq? So we denote the magnitude of a vector by placing the vector in between brackets. And for a general definition, for a 2D vector, the magnitude would be equal to the square root of the x component squared plus the y component squared. If it was a 3-dimensional vector, you would just add the z component squared. So the magnitude of pq is equal to the square root of its x component squared, 1, plus its y component squared, which will become a positive term, so negative 3 squared. So this is equal to the square root of 1 plus 9, or 10. So this is how we calculate the magnitude of vectors. Next, let's discuss position vectors. So a position vector is any vector that starts at the origin. So for example, if we have the position vector r equal to 2, 3, how would we plot that? Well, again, it starts at the origin, so our first point will be just at the origin. Then the ending point we would just plot at 2 coordinates in the x direction, 3 coordinates in the y direction, which puts us here. And again, we're going to draw a straight line from the origin to this position. We are starting at the origin, meaning we're ending at the coordinate 2, 3. So we're going to draw the arrow facing towards the ending position. So this would be the plot of r. Again, it has 2 units in the x direction, 3 units in the y direction. And again, if we want to calculate the magnitude of r, we would just take the square root of its x component squared plus its y component squared. So that would be equal to the square root of 4 plus 9, or the square root of 13. And just to be clear, the magnitude is actually the numerical value of this line here. So this distance is equal to the square root of 13. So you can see we start to form a triangle with its components. And this will bring us to the next thing I want to teach. Okay, so the last thing I'm going to torture you with in this video is the triangle inequality theorem. So let's say I have vectors v and w. Now, this theorem states that if I took the magnitude of v plus w, this will always be less than or equal to the magnitude of v plus the magnitude of w. And if I were to illustrate this, so let's take a vector v like this, and then if we have the vector w like this, so this would be w. What would be this part, this left side of the equation? V plus w. Graphically, that would just be starting at the beginning position of v and ending at the end position of w. So it would essentially complete this triangle here. So this would be v plus W. And the length of this will always be less than this length and this length added together. Thank you for watching my video. For any questions or comments, feel free to leave them in the comments section or by email. Thank you and have a great day.